Greetings, Hacksters! Welcome back to another Hackster Cafe. I'm very excited to introduce a couple of people from Lumia. We have the CEO and founder, Maddy Maxey, as well as Jennifer Enriquez, who's going to show us some cool demos today. How's it going?
Yeah, going well. Thanks for having us, Alex.
So stoked! We've been working on bringing this to you folks forever, and I'm so excited. And the occasion for today's interview is that you have a new kit. Could you tell us a little bit about that? What's going on?
Yeah, absolutely. Sometime last week we launched our tactile sensor developer kit. We developed a new super low force touch tactile sensor that we're calling our smart skin sensor. So this kit includes both our piezo-resistive sensors as well as the new smart skin sensor, and also a three-finger glove, which is shown here, that you can use to
Ooh.
collect force data from different objects. The kit is still really new. We just kind of push it out there for the community. And so we're excited to hear feedback, to learn from engineers and to get it in some hands.
Awesome. And I've realized I got overexcited about the new kit. I forgot to ask you to tell people what Lumia is and what you do in general.
Yeah, of course. So Lumia makes soft and flexible electronics. We've been working on electronic textiles for the past 10 years or so. Our specific way of making electronic textiles is using a conductive mesh. So we don't print our circuits. We don't knit our circuits or weave our circuits. We use this mesh. And that's sort of what makes our product have a unique set of performance features. It's also what makes our product really good for tactile sensing and for putting on curved fingertips or curved
Ooh,
surfaces like fingertips or palms. So we're really excited to see, what these sensors can do in the robotic space.
really cool. And you've been working with the automotive industry and other industries for a while. I feel like one of the biggest maybe preconceptions people have around e-textiles, and maybe you can speak to whether this is true or not, but is that it's mostly about clothing. And so on your website, you talk about how you have you're in automotive, robotics, and AR and VR, and medical and wellness. Obviously, there's going to be some overlap there, but on your new kit, you show, for example, there's a in our video thumbnail, there's a robot hand gripping with the three-finger sensor, but also on your website, there's a human doing it. What do you feel like are some of the most unexpected uses that you come up with for this, and what do people expect? And does that compare to like how you actually spend the most of your effort?
Totally. Yeah, you hit on a topic that is so near and dear to our hearts at Lumia. So people hear e-textiles and they always think of clothing and fashion. And I think that there's something about smart clothes that just really captures people's imaginations. But sort of the reality is that it is very difficult to get apparel companies to find a business case that makes sense for them using e-textiles. If you're a company that sells t-shirts, then you're selling those t-shirts for $30 each and you're selling thousands and thousands, maybe millions of them. And if you put electronics on it, the electronics are going to add a ton of money to those unit costs. And realistically, you're only going to sell a smaller quantity of them. It just kind of doesn't make sense for a lot of these customers. So generally who we work with are customers who already use electronics and soft and flexible materials in their products. That tends to be automotive interiors, which are covered with textiles or leathers. They also have a bunch of electronics built into them. Also robotics, especially for soft robotics, or now that people are building humanoids, often
Mm.
you need something kind of soft around the hand and you need to package electronics in it. Medical and wellness, also you need devices that can go around the body, feel soft and comfortable, but have electronics. So we see e-textiles as solving electromechanical problems. If you don't have an electromechanical problem, if you have a plain t-shirt, you have no electromechanical problem, then adding an e-textile to it doesn't always make sense. So yeah, I think it's a really interesting thing about being in this industry because it's very unintuitive that way. Like building a business in this space, you think, oh, I should talk to Nike, but I wouldn't suggest that that's who you talk to. But I'm
Ooh,
someone out there has had other experiences.
gotcha. I did want to show. So, for example, you mentioned on your website that it's drapable. Like that's such a huge contrast from other options. Like you're saying, it being like soft and molding around the body really well. I just wanted to show people like how I know that Jennifer, you have some good demos and stuff, but just really quickly, like this is a piece that I've had in my toolbox for a while now, and I did build a robot with some Lumia stuff, but this one is one I didn't use yet, just to show like how thin and how flexible it is, and it's got this really soft surface texture, as well as like I'm a huge sucker for like glossy on matte design, but like it's beautiful. I know that you usually wouldn't have this on the surface, but you could. And I did on a robot, and it's also self-adhesive. So, for example, robotics, you can really just like stick it on the outside on there, peel and stick it, and then you've got your electronics there, and then these flexible connectors and all that good stuff. Ooh, yeah. So I feel like this is one of the huge ways that you differentiate yourselves from other, you know, as you say, electronics options. And then you also have a broad variety of offerings that you do. It's not just like a bunch of light up LEDs. You've got like these really thin tactile interfaces. You've got heaters. You've got antennas, and all these different things. What do you find that, for example, the automotive industry uses most? Is because I feel like the heaters to me suggest like a heated seat in a car, but I don't know.
Exactly. Yeah. And also thanks for showing our sensor. It's always nice to see it in someone else's hands.
Oh, I love
And yeah,
those.
yeah, for automotive, heating is a great application. Also, heating combined with sensing. So there are certain things that you need to package in the automotive interior. And this comes back to the electromechanical problem. So, for example, in a car seat, you have to have something called the seatbelt reminder. It's the thing that yells at you when you don't have your
Right.
seatbelt on. And in a lot of cars, people also want seat heaters. And kind of the issue is that you have to often package the heater around the seatbelt reminder, and it can create a cold spot. And you also then have to package two items into the seat, which just kind of like extra labor and stockage. So if you can combine heating, for example, with a capacitive antenna for occupant sensing, then you just have one part, one surface to put into the seat. So it's that kind of stuff that we work on for automotive. It's like packaging, making things sort of just easier to install, combining parts together, and it tends to be mostly heating with some kind of like capacitive sensing.
That makes sense. Yeah, I hadn't thought about like stacking them like that, but absolutely. So, on one of your pages here, I saw that they have. Is this just like a stripped down version, or is this an actual consumer version? Do all of your parts come in the same sort of colorway, or can you get like, if I worked with Lumia, could I get a custom colorway of sensors? I know they usually go on the inside of stuff, but just for
Yeah, totally. We have different stackups. And so the stackups do end up coming in different colors. The stackup that we have for our tactile sensors, so all of our sensors or components are encapsulated in a thermoplastic polyurethane. Basically makes
oh,
them protected from particulates in the general environment and insulates the electronics. So we want, we like that, insulated electronics are good. And so this TPU that we're using is a more expensive TPU. It feels really soft, which is nice.
mm,
It is really soft in general. So it's nice for sensing. It's nice for like maybe sort of devices where it might be really close to skin. For automotive, for example, we use a different stack up that's actually a little less soft and drapey, but is really
hmm.
durable. That's important for their applications, and it's also super cheap. And then the picture that you were pulling up before is a third stack up that we were experimenting with. It's a transparent stack up that has adhesive on both sides. So actually that opaque
Oh,
color you saw gets peeled off, and then the
whoa,
whole thing is transparent, and you can just like heat press it to something on either side.
cool.
Yeah.
I bet that looks amazing. I know that aesthetics isn't everything, but for me, absolutely is a huge part. And you're always showing your serpentine connector cable here, which is so cool. So not only do you make these components, but you have the individual um, flexi cables and stuff. So you mentioned that this kit came out of a series of over 100 interviews that you ran, which I found really interesting. Let me find the exact description that you did here really quickly. But it was part of a grant, right? Actually, maybe you can just like jump into telling us about that a little bit. I'm really curious about this series of interviews you did, who you chose to speak to, and what were the sort of biggest takeaways you got from that?
Yeah, of course. It also was a lot of who would speak to us. We
Ooh.
did, so we got a National Science Foundation grant, and they give you the opportunity to do ICOR, which is like their business development customer discovery program. You
Mm.
basically interview 100 people over the course of 6 weeks, and we ended up focusing on interviewing robotics engineers. But it really is kind of a scramble because, you really need to just like reach out to people and be like, hey, can you tell me stuff on a call like tomorrow? Thank you. It's like, so it was intense, but we just really started to see a pattern emerging around the interest in tactile sensing. And we thought that a developer kit was just like a great way. Exactly. Yeah. ICOR program. We thought that the tactile sensor development kit was just a great way to get ourselves into this space. Like, we know it's still kind of early, but we want to be there as the industry grows and shows what we can do. And iCore just basically gave us a laundry list of features that engineers want. So we were like, great, let's build what we can, let's get it out there, and then we can always iterate.
Yeah, you mentioned tactile sensing as one of the biggest things that came out of that, and I'm wondering if that how much that informed your eventual decision to really market this as a humanoid robotics centered developer kit.
Definitely. Yeah, I mean, we saw a really clear pattern that for hand-shaped end effectors,
Mm.
tactile sensing is useful. For other kinds of end effectors, sometimes it's useful, but it's not always clear. Like, it depends a lot on what kind of objects are being handled and what the use of that robot is. So generally, we're focused on dexterous robotic sensing, and then we
Mm.
just sort of highlighted that into humanoid because it's like cool and new.
Yeah,
But
fair.
generally, it's dexterous. Dexterous is like a broader category.
I would agree that it is very cool.
Yeah.
uh, so, let's see. What do you think are the most what do people usually ask the most about your products? Because they're this very specialized piece of technology and tend to be focused around some industrial areas that people don't necessarily contact much if they're in the DIY electronics space. A lot of our audience is well, we have all across the board. So we've got like professionals who are working in manufacturing and all that good stuff, and some of the industries that you've mentioned. We've got people who are building stuff in their garages. We've got kids who are learning stuff in schools. And what do you think are the most common questions that you get from people who aren't immediately familiar with your technology?
Hmm. Yeah, actually, that the mesh circuit thing can take some time to explain. A
Mm.
lot of times we'll have meetings with customers and we'll be like, so we don't print our circuits, we make them from this mesh. And then 2 minutes later, they'll be like, so the printed circuit, it's
Yeah.
because it's such a way of making these kinds of materials. And I think over time we've learned that that's, you know, unique. It's doesn't necessarily mean better or worse, but it has unique performance things that we can share with potential customers. Yeah, I would say that the mesh thing can sometimes be a little bit of a surprise. And then honestly, what you touched on in the beginning, where, when we tell people we work on e-textiles, their first reaction is always like, oh, like light up shirts. And then you have to kind of like walk through this process to be like, well, not exactly. Like maybe you could make one, but we don't really make those, that sort of thing.
Absolutely. And you've got a guide on Hackster for how to use Lumia with Arduino, which you just published recently. So anyone who is interested in getting started with Lumia, tactile sensors especially, I mean, there's this format with the Mega Matrix. You've got smaller ones in various form factors, and of course this three-finger sensor. Just tons of really cool stuff that you're sharing to make this accessible to people and help explain to people not just how to use your technology, but sort of concepts of design and stuff. What would you say are some like big takeaways that you've learned from working with companies who are actually embedding this in products? You have, for example, mentioned your high durability version for automotive. What about like tailoring it to other industries?
Totally. Yeah, and it was really fun working on this for Hackster, so it's fun to see here. And yeah, I think something that we've learned about working on tactile sensors for other industries, especially for things that go on like hands or gloves, is that it's still emerging in a lot of ways. It's like I think one small detail is you can evaluate a sensor on a desktop, but once you
Mm,
put it on a glove and you put that glove on a hand, how do you know that the pressure that you're sensing isn't from deflection of the fabric on the glove versus from
right.
encountering an object itself? And I think that there's just kind of a lot of open questions about doing this right. Like, what is the tolerance for clean data? What is the tolerance for repeatability? What is the tolerance for sensor production consistency? And there's a lot of people in the space who know a lot more than we do. But even with working with some of our customers, we'd be like, okay, great, which test method are you using? And like, unless you have an Instron machine, it's really hard to figure out even the test method. So that's
Huh.
why in our kit we include like a static weight testing method where we're like, if
Yeah.
you don't know what method to use, just do this.
That was one of the, and they look, to be really superficial here, the weights look pretty cool. When I looked at the kit, the materials that you sent over before, I was like, whoa, what are those star things? Let me see if I can find these. Um, I know you've got a
Yeah,
picture of it somewhere. I just have to
is it
find
the
it.
X's on the sensor? Oh, no, the weight jig. Yeah, the weight jig I think is down lower on the page.
Ah, ha, ha, ha.
Yeah, a little bit down.
There we
Okay,
go. Look at these
yep.
thingies. I mean, I know you've already looked at them, but everyone
Oh,
else, look at these cool things. So you provide all these pieces for people to be able to like test out how this stuff works in different environments before they actually trying to build it into something that's so cool.
oh, thank you. Yeah, but yeah, we heard this really strong message in iCore that engineers wanted to be able to get data from a sensor in 15 minutes or less. So that was one of our philosophies in the
Mm.
kit. Like, we don't want you to get the kit and then be like, great, but what, like, now I need to wait again to like order some weights or like get on the Instron or something to know if this is working. We're like, hopefully here's everything that you need to just like sit at your desktop and get it going in like 15 minutes or less. That was really our goal with putting this together. Yeah. I also see we have a comment. Joe
Oh,
asks, can it get wet or be used in challenging climate environments? And yeah, Joe, our parts are encapsulated. So we did internal humidities testing, just basically sealing humidity strips into the insulation, and we're not seeing ingress or anything like that. We hope to do full IP testing at some point, but for now, we say you can get it wet. We've done also wash testing. So, the pressure sensor is not so much, but some of our heaters and other components you can put in a washing machine. So they're pretty durable to external environments.
really cool. I've got
So a hey for Maker Brains who says hey. It's
oh
it.
yeah, we got a interesting from Joe as well. Awesome. So you did a bunch of like over 100 interviews before you released this kit. I'm curious, after developing the kit, have you done, I'm sure that you have, but what kind of testing did you do after the fact to make sure that this was going to sort of fit the needs of the people that you had been interviewing and you want to target with this kit? And
Yeah, definitely. I mean, I
kind of
think we're just
feedback?
starting to like collect feedback on
Uh-huh.
what people like and what they don't like. Somebody suggested, for example, that we make the weight jig transparent so that you can actually
Oh,
see the part underneath, which is like, oh, great idea. And that's so easy. It's just filament change. So sure, so we're starting to get that kind of input come in. Some people have said they want a 5-finger glove instead of a 3-finger glove. So that's
ooh,
also something to take in and adjust. And then for sensor performance, we've definitely gotten feedback that we need more information on environmental robustness, like operating temperature, a bit more information on general sensor performance. So we have a lot of testing to do over the next few months.
yeah, I was actually curious about, so in terms of like current things that you produce and future things that you may or may not produce, I'm assuming that the heater may have like some kind of temperature feedback circuit within it, but I was wondering about like other uh, flexible sensors. So you've got pressure ones and stuff. Have you thought about doing, like a more separate sensors and things? And obviously things like displays sort of go into a whole other genre of product, or like actuators or whatever. You're very much into the sort of like flat laminated objects. But Yeah, in terms of things that you might end up producing in the future.
Yeah, I think for now, more so than expanding into new functionalities,
Mm-hmm.
we're really trying to dig super deep on the functionalities that we think are most exciting. So like heating for automotive interiors, it's a resistive heater. It sounds so easy. You're like,
Uh-huh.
I don't know why we need to spend years on this. But there are so many important details. Like there's a test that you do for armrest heaters where you basically like take this piston and like hit the part over and over again.
Whoa!
And yeah, fun. And making parts survive that is just challenging. Like you have to find the right materials with enough tensile strength to resist that. Getting really good consistency between parts. So making sure that they
Mm.
have, really, no matter where you're getting, like between different rolls of mesh and wherever you're cutting out in the mesh, making sure that the parts can pass a QA process. Also, making the parts cheap is really important for auto, for example. So that can
Mm.
require resourcing many materials to find cheaper but equally, part materials of equal performance. So we're like really just going deep into the rabbit hole for that application, and we're going deep into the rabbit hole for tactile sensing, and that's really what we're working on for the next, years. Who knows? However long it takes to get it right.
And that makes a ton of sense, especially because what you do is so specialized. Like, for example, the way that they're made does so much for the applications that you can use them in. But then also it means that you need these like specialized different versions, because once you have the object is a little less customizable, you have to and you're making these versions that are like multiple sizes and like very flexible and stuff, so that you can kind of adapt these very thin, very drapable objects into whatever shape they need to be. And I gotta share something embarrassing that I did, because I wasn't thinking about this when I was like, oh, if I cut the serpentine like connector in half, then I have two of them. This was years ago, so don't judge me too much, but I did cut it in half, and I was like, wait a minute, wait a minute. I can't solder this. Or, maybe if I tried peeling it apart or something, but like that was not my smartest moment in the world. And then it's just like, what you're doing is so like, you're as you say, taking the things that you're specializing in and just going really deep on them so that people can get exactly what they need out of those specific things. It makes so much sense. And you've got this custom pressure sensor page, so people can create different weird sizes and shapes of these. Is there like a particular one that sticks out to you as especially interesting custom pressure sensor you've worked on?
Yeah, I mean, there is one, but I'm not allowed to talk about it too
Gotcha.
much. It's like 2 years making this really special pressure
Ooh.
sensor. And it's like, as you said, you'd really just, or as I was saying before, you just like really dive into the rabbit hole. I like being in the rabbit hole. Like this is, I think
Mm.
that my like joy comes from being like, we spent 5 years making this little tiny thing and it's perfect, and it's never perfect. But yeah, that was, I think, one of the like most interesting developments that we did for pressure sensors. We also have done some like larger pressure sensors more for body weight, which can also be fun. It's sort of like pressure mapping. But I think it's really like the hand fingertip sort of ones that are most interesting, because it's just this like, getting it over the curved surface is an interesting problem. Getting light touches is an interesting problem. Like those are, really our favorite.
Yeah. Now I have a bit of a random question. So I've noticed this before, and then on your website again, you have. I feel like this might be one of those rabbit hole things. So on some of these, you've got straight up sort of little dome shapes for the connectors, and you can connect to these with like alligator clips and whatever. But then on other ones, you've got these little sort of like irregular tooth shapes, and that's showing on this page as well. I'm really curious, is that like a functionality thing, or is that a design choice that's more
Yeah,
visual,
so
or?
we changed it because I don't think anybody's really using them, but they were meant to help you understand the rows and columns. So
Oh.
for the 3x3 pressure matrix, you can see, I mean, the shapes are just like two different shapes, but you can see that like all of the same shapes are rows and all of the other of the same shape are columns. So
Oh,
that
no
when you're like
way!
alligator clipping to them, you can more easily figure out what you're doing.
That's so smart! Check this out!
Yeah. I don't know how much people really now all of them are just squares. We just changed it, but it was fun. The Gigi on our team came up with this idea, and I think we all really liked the like user interface design of it all.
I'm a huge fan of things like that. This is one of my favorite things in art, especially, is when there's like some cool visual thing or like audio thing, and then suddenly you realize that it has meaning, and it's like, oh, it's like hidden like an Easter egg almost. So that's, oh, I'm flipping out internally and a little bit
Yeah, you
externally.
found the Easter egg. So
Totally. So another thing I wanted to make sure that we cover is that with this kit, it's not just a bunch of hardware that people get. There's also uh, oh my gosh. Yeah, okay. 2 hours of Lumia engineering support, which alone seems like a huge value for working with a developer kit, because I've often gotten things that are sort of like, um, the a company's first iteration of something, or my first time working with a developer kit, and there's all these little things where it's like, sometimes we have a direct line to the company, but sometimes not, and it's like, who do I talk to? I just want to answer this one thing. So 2 hours of like direct support from the team is incredible.
oh yeah, I hope that people will find it useful. I mean, as you may have noticed, the kit's a little on the higher price side. We're kind of targeting um, companies who are building big robots with this, and
Mm.
so we imagine that down the line they may need some customized sensors. Like we're not really sure if these will all be the perfect fit for what they want, and so with that engineering time, we can really understand what they're doing. We can provide feedback. We can make the onboarding process really really easy, partially because we think that there might be a long-term relationship with some of these customers, so we want to be there from the very beginning.
That makes sense, and people can even book a Q&A before they even order it, which is kind of cool.
Oh yeah, and if you do, you'll talk to Jennifer, so you can see, yeah, get to be familiar with Jennifer's face for the call. Yeah.
Speaking of which, Jennifer, would you like to show us what you've got over there? Because I know that you have a couple of cool things to show.
Yes, absolutely. So I am here in the Lumia lab with the sensors to give everyone a sneak peek. Actually, I might have to remove the blur of what exactly they can hope to find in the kit. Actually, give me one moment. I'm
Sure.
trying to see if
And
I
then,
can edit the camera. Wow. Oh,
while she does that, everyone, if you have more questions, feel free to drop them in the chat. It's going to be good times. And I'm going to take a drink of water.
okay. We are actually good to go.
Mm,
Couple quick seconds. So
awesome.
here on the table, you can see what the sensors are looking like, and you might notice some of them look familiar.
Mm.
This is the single force sensor. So this is the one that we were just looking at on the website as well. And you might notice there's quite a lot of sensors here, and it's actually something that came out of the discussions with engineers as well. So from an engineering perspective, if you want to get the full range of like sensitivity and force detection, you need to start combining sensors, because our force sensors, the ones that everyone knows and loves that have been on the market for the past couple of years, the piezo-resistive ones, they can detect forces from around like a gram up to a couple of 100 grams as well. So a pretty solid range, and they're good and handy for a lot of applications. So this is the mega matrix, and this being the mini matrix. But once you really start getting to that really like delicate level of sensing that some robotics applications are interested in for a lot of that like really fragile and light touch, that's when you start needing slightly different technology. And that's where we started developing what we call our tactile sensors. And that's these three over here. So you'll have the flat, and this is also just another example of showing just how like trapeable, flexible, and floppy they can be. Look like this. Very, very nice. So this is the flat one. This is what actually utilizing capacitive technology. So that's what's going to help make this really, really light feather touching, detecting of even like below 1 gram of force. So very tiny. This one is going to have different multiple touch points. So this being the connection point, this being the detection point, and this is the one that will be in the glove that you saw on the website as well. And then here we have our familiar serpentine design, but now in our tactile sensing form, in case someone wants to use it in a more different form factor that requires a lot more of that like flexibility. So these are the tactile sensors here that will be included in the kit, and then the regular matrix piezo-resistive sensors that people can experiment with. And as you, the one that you also had in your possession still had the adhesive backing, but people can go ahead and like stick it on wherever if needed. So if they're interested in even potentially like putting this on a more flat surface, like a robotic palm or anything like that, they're free to do so. So what we really want people to take advantage of is being able to experiment with that like force sensing technology, try it out in different form factors, not be restricted with the form factors that came in with. If they had only gotten one, they're kind of like restricted with this. But since they get the full range of extra stretch, different sizes, even different sensing, with this having one sensor point, this having being our 3x3 matrix, they can really start just like playing around and seeing what tactile sensing can look like for them in their applications, and whether in the robotic hand, maybe slightly different end effectors. And I can try and see if I can
Ooh.
quickly showcase just how easy it is to get set up. So this is in the kit, like it's as simple as just testing it out with a preloaded Arduino board. And let me see if I can quickly share my screen as well once I get the readings up. But it's really meant to be super, super simple and fun as well to just get tested with a lot of the information. So let me see if I can share my screen.
And in the meantime, we have a cool comment from Maker Brains who
Let
talks
me
about
see.
working with a doctor to develop a toe mapping
Can you
sensor
see
system.
this
I
screen?
don't see it yet. Oh wait, no, yet, no. I'm
Nope. Let's
holding
see.
on just to see it pop up. I'm gonna
Oh,
have to enable it, and I'm keeping an
that
eye on it.
is on me. I had
It's all
chosen.
good.
Here it is. Can you see this?
Gotcha.
All right, so a little bit of that was just for me moving it around, but you can just show like as I click each cell one by
Ooh.
one, you see the different colors, that's the different cells. So it's really important to really like have this easy to visualize and read information, and it's as simple as just setting it up with the board and just like this within 10 minutes. We even have a little demo on our website that shows within under 10 minutes you can pretty much get this running and set up. And so we really wanted to make tactile sensing and experimenting with this type of information more accessible for a lot of people as well, especially since it's a team effort to start making use of a lot of this information as well. So very easy. This is me touching the different cells on our 3x3 mega matrix that I was just showing. If I throw 3 as well, this is 3 in a row, 3 in a column. Very, very close in performance.
Ha!
So very fun.
It is extremely fun. I love seeing this stuff. Oh, look at it go.
Oh, and then obviously here is the glove as well. So this is where it's going to have a lot of that like tactile technology. And right now we started out with a 3-finger design because a lot of robotic models out there use that type of design, but it's meant to be adjustable as well, since even within robotic hands, there's a lot of different variety in the shape, size, thickness of it. So we wanted it to be adjustable, since that is the main goal, really being able to customize even with what you have in the kit. So it'll be
Yeah.
adjustable and they'll be able to just slide it on, and just like that. With the tactile sensing technology, they'll be able to start really like reading into and experimenting with the tactile information.
Awesome. Thank you for that demo. And just before we click off of here, I'm really curious. It looks like you've got maybe soldered like a ribbon cable to the connectors there and then covered it with electrical tape. Is that the...
Yeah, just to keep it safe.
Gotcha. Is that
Yeah, just for easy experimenting, prototyping within the lab as well. We want to be able to like carry it around. But yeah, let's see if I could Actually,
Oh,
it's
I don't
pretty
want to make you
protected
do
right
that.
now, but
I know
I
you'll get
have
adhesive everywhere after you do that.
this one as well. So in this case, we had taken advantage of the bigger pads because it's easy to solder onto. So if someone
Right.
prefers more surface area to work with, there's that option as well.
And I think that maybe it was pointed out in the past that like if you want to use alligator clips with this, you can just literally like snip off that lower row of headers. Am I making that up?
Exactly. Exactly. So if someone is not up to the task of soldering the really, really tiny ones, they can just like snip off this lower part and solder onto the bigger pads.
That's so cool.
Or alligator clips as well, yeah.
And am I making this up that if you have one of the larger pressure matrices, you can also sort of like cut off one, like within certain constraints, cut off some that you aren't using to get it to fit somewhere?
I'm
I
not
don't want to misinform people, but I feel like I remember something like that.
Yeah,
I
unfortunately, if you cut into it, it will stop working.
That
Probably.
makes sense.
We would not recommend only for like extreme. It's like the extreme sport. Cut at your own risk. But yeah, you'll probably end up breaking it.
Maybe something that you're
Maybe
not planning on
someday.
actually using in your product or project or whatever. Don't be a me and cut your thingy, your like connector in half, especially because that absolutely was not a smart move. I'm guessing this was like a 2 or 3 a.m. kind of decision. Like
When we
was
make the
not
best decisions.
was not was not the best decision. We've got a couple of follow-ups on this doctor situation. Make Brain says about the doctor who is developing pressure sensors for different types of toes. This doctor believes that due to our modern lifestyle and constant exposure to flat surfaces, human feet have increasingly developed flatter toes, losing their natural curves. And that Maker Brains believes this is Lumia is well suited for this kind of analysis as it could accurately map pressure points across the foot. Truly fascinating. It
Cool.
is fascinating.
Did you end up making the pressure mapping system, Maker Brains?
Ah, yes, good question. Very curious to see what the outcome of this potential collaboration was. Okay, let's see. I know I got a bunch more stuff to ask you about, and I gotta fit it in here somehow. So, we talked about the connection method. I'm really curious about therapy bots. And actually, okay, have you been approached about, for example, there's this therapy robot. The most famous one, I think, is Paro the Seal, who's like a therapeutic bot. And this is kind of what I was trying to build with my projects, which is, so it's like kind of self-serving to ask about this, and the page is gone that I had pulled up. Well, anyway, have you talked to anyone about more sort of like human-centered robots? So there's like, you know, a whole toys area for like little kids and stuff where the durability comes in massively helpful, and like the softness. And so this Paro is basically like a baby seal robot that like sort of like trills and purrs and like makes little noises and like moves around based on like responds to people like petting it, and that's the kind of thing that I'm trying to develop as well, but in a more personalized form factor. Have you worked with anyone building like human like huggable robots or toys or therapy bots or anything?
Oh, we talked to someone a few years ago who was working on a therapy bot.
Ooh.
It didn't end up going somewhere, but it seemed really cute and useful. Yeah, for you, is your robot going to be like Roko version 2 or different
Yeah,
kind of animal?
pretty much. So I unfortunately I just recently published this project that it turned out I had kept unlisted for ages because I think I was still working on it, hence the WIP, but a little raccoon guy. And I realized later on that I forgot to put a tail on it, which is the most ridiculous, like that, it's a raccoon, it's gonna have a tail. But anyway, unfortunately Roko is in bits currently, but I can show, it was inspired by these little raccoons that I ran into in real life. In my old neighborhood, but we had this like situation with like this is actually a soy milk bottle, and I'm so sad about the lack of ears. Don't look at it, but like you can see how this was like wrapped around the top of the bottle, and it was a perfect little like raccoon face type of situation, and this just worked really well for like wrapping it around, and inside I had this heater that was gonna like help me just like be warm and stuff. And my favorite thing about this experience, I'm sorry, this looks terrible, and it is terrible because I was doing it last minute. But anyway, we got some connectors on these paws and stuff. My favorite thing about this whole
Wow.
experience was bringing it to SuperCon. Yeah, just pretend it's a lot cuter, okay? I pulled down the like furry outer part that was on there before, and it's got like these little flexi paws, also made of TPU, but a different type of TPU, which have now gone into a permanently contracted state. Anyway, the coolest thing I found about that was like bringing it to SuperCon a few years ago, and handing it to people, and then being like, "What is this?" And then all of a sudden it purrs, and they're like, "Ah!" And like this moment of the big reveal, which was amazing. Let's see. Anyway,
It's also like the cutest application of any of our parts. Like using the user interface for the raccoon, it's just like adorable.
well, that's incredibly flattering. Thank you. I definitely want to get it up and running again. Here's some photos from SuperCon with other companion bot people. We got my friends Angela and Aj, who are legends. Anyway, so enough about that, though. I absolutely am planning on doing a new version and would love to incorporate some of these little flexi devices in it. We have an answer on your question from MakerBrains as well. I tried with flexible PCB, but this is the first time I'm hearing about Lumia, so I definitely should try with Lumia. Absolutely. There you go. Yeah, and we've got a bunch of links in the description to interesting stuff that you can check out if you're curious about exploring more. Lumia has done a number of things with Hackster, and I'd love to dive into some of that history, actually. So, apparently 9 years ago, it seems, according to what I'm finding on the internet, there was this thing called America's Greatest Makers, which is where I met Maddy, because I and Monica, who was at Hackster at the time and is at Avnet now, were applying to be part of this like reality show. And it did end up happening. I didn't really follow it much, but I would love to hear, Maddy, about your experience with this reality show that was focused on makers.
Oh wow, there's Jonathan. And Jonathan actually was our mentor for iCore. So he was part of this whole interview process. Yeah, he's in like let's see, like I think it's like the fourth video down. Maybe that's a good way to describe the process. Like we met I met lots of interesting people, and it's been interesting to see how those connections carried on. Our team was eliminated super early, so I think we were eliminated like the first round. Our prototype didn't work.
Oh no.
And it was like that trauma when you do a live demo and the hardware doesn't work. It's just like helplessness. But it was a really cool experience. During the filming, they also didn't allow us to leave the hotel room, and I definitely... or not the hotel room, but the hotel complex.
Wow.
And I definitely left. And, you know.
You're such a rule breaker.
I know. It was like, you can't box me in. And I got a nice, talking to about it.
Do you think they kicked you out because no, you said why, but maybe because you were just too...
Yeah, maybe that was it. They're like, she's a liability. We can't have her on this show. And somebody came in and sabotaged the prototype, like cutting wires. We don't know.
Yeah. Who can say? What I'm really fascinated by failure modes. So like, what happened with it?
Yeah, definitely. So we were trying to use a double tap interaction to make the prototype light up. And I think that it's kind of an inconsistent... It's just really hard to make a double tap consistently work in a prototype that you built. So it's like basically double tap was the only way to make the system like change modes. And you have to get the timing just right. And there was no backup switch. So it's like the double tap was not tapping, was not registering tapping.
No.
And it just like couldn't switch modes, and no one was impressed. So
that's how it goes. Yeah, I imagine there was a lot of pressure you were operating under as well, like adding to just like the experience of like, it's not doing the thing, and then like, if you're trying to time something specifically, then like, your pulse accelerating almost certainly doesn't help.
It does not help. Yeah, I mean, I think maybe I was like 23 or something. I don't know. I feel like a bunch of stuff I did in my early 20s, I just didn't have like a formed enough prefrontal cortex to like, get what I was going on. I have no bad memories. I'm like, that was crazy. You know, some people have their like, I used to party all night as a teen stories, and mine is like, you know, we got kicked off this TV show for electronics prototyping.
Yeah, I mean, so our team didn't even make it into the show, but I still like. I remember running into some people that I'd seen from around like the Bay Area, but it being the first time that I saw you and the cool stuff that you were doing, it's like, this, and you're so glamorous. I was like, I know that that's not the most important thing, but it did strike me. I was like, ah. Anyway, enough about that. But yeah.
Yeah, I think there was such a strong, I mean, maybe there still is, but I just don't live there anymore. But there was like such a great community around this like Autodesk prototyping,
Yeah,
hacking crew. It was such a fun time to be around the Bay Area.
and it's just been so cool watching y'all's product continue and like going in, like you mentioned, so hard on like one particular area of focus and just like seeing how it evolves over time is so cool. I'm also curious, like if so one of the things about this reality show, and I almost wonder if you have any words for advice for people who might get approached about similar shows. Is that I remember there was an incredibly sort of invasive like privacy agreement where it was like, you know, we can hide cameras anywhere and not tell you about them and film you at all times. And as a person who's like very sort of introverted and like privacy focused, I was like internally screeching. Are there any other like takeaways that you would have from that experience for anyone who's thinking about doing like a show or a similar experience?
Yeah, I mean, we left so early that I didn't like experience too much of that, like somebody filming us when I wasn't expecting. But I do think that more and more for like my career, I think about if this will actually help me get closer to what I want and where we're trying to go. I think in a lot of cases, like anything publicity related, people just tell you should do, like, oh, it'll be good, you know, somehow it will be good. But I think it actually, you know, that show, I met some interesting people, but it's not like it got me a job or it got us investment or it got, I don't think there was like any, some of the training was really interesting, but it's not like it gave me something that, you know, I couldn't have gotten otherwise or, yeah, so I feel like for any publicity stuff, it's just kind of important to think about what you want to get out of it and making sure that everything's sort of like aligned on the, you know, aligned towards where you're trying to go. But that's how I think about things now.
That makes sense, yeah. Resource allocation and opportunity costs and all that good stuff. I'm trying to organize my own life right now, and there's a lot of that, like especially like having experienced some burnout, just like figuring out where you spend the energy you have when you finally realize that it's limited. It's like, oh dang, yeah.
Yeah, but what are you changing now to try and avoid burnout?
Oh, so many things. Let me see. I guess just like deciding what's most important and what's not most important. So, really keeping an eye on what's coming up in the future, and also just like, you know, can this area of my apartment stay a giant mess for a while, even though I don't like it being that way? Like, you know, there's a lot more other things that I want to like get out the door. And like if this area stays like a massive cluttered mess for a while, that's okay, and we will live. And honestly, like it's usually various amounts of clutter, but like just, you know, figuring out constraints, like what are the necessary things and what are the things that I can like live with. Yeah, I don't know. But like you mentioned, sort of like figuring out what your goals are and which of the available options are going to actually meet those goals. So. I'd love to hear a little bit more about your journey specifically, Maddy. So, you know, obviously 9 years ago you were doing a reality show for a bit, and you mentioned you've been doing Lumia for 10 years at least at this point. People always ask on our comments, like, you know, what did you study? And that doesn't necessarily lead to what you end up doing professionally, but I'm curious, did it? Like, what did you study and how did you end up getting into this?
Yeah, so I would say what I ended up doing professionally through Lumia actually informed what I studied because I went back to school
Ooh.
late. So I started off wanting to go for design and then ended up doing the Teal Fellowship, which basically gives you money to leave school. And it's part of why I was able to start a business. Honestly, it gave me some cushion in time to figure out what the company could be. And then I went back to school and studied material science and engineering because so much of our work was so tied to material testing and evaluation. And I just really wanted to have the knowledge and background for it. I felt like it was important to, again, like go as deep as I guess you can always go deeper. Like if you get a
Mm.
PhD or something, that's deeper. But I wanted to go deeper than where I was into what we were doing. So yeah, I think like each step was kind of just like following a breadcrumb to a next step, which I think is not traditionally the way somebody sets up a business. Maybe we would be more successful if I set it up a more traditional way, but I think a lot of our longevity has been just kind of like always doing the next thing that makes sense to do. So, it's like a customer asks us, oh, can you put an NTC in your heater? And then we'll be like, well, let's find out. And then we investigate and then we know. And now we can have a heater with an NTC. Or, we'll be like, oh, this market seems really interesting. Let's investigate. Like the iCore, let's do a bunch of interviews. Let's understand what's going on here. Oh, we can make a developer kit. Let's put that out. So it's been very much so just like kind of this, yeah, exploration, understanding what customers might want, trying to fulfill their need as best we can, and getting paid along the way, and that's sort of how the business keeps rolling along.
Absolutely. And I was just snooping your LinkedIn a little bit and found out that you are part of the eTextiles A team. What's the deal with that?
Oh yeah, I think I should also update that because I haven't participated in a long time. But it was the
Oh, yeah.
Association Connecting Electronics Industries. And a few years ago, especially when Lumia was like a little bit earlier, I worked on some of the standards. So we had these groups where we talk about standards and new requirements for this, emerging industry of electronic textiles. And I was part of those teams, attending the meetings, talking about the standards. Now I don't attend as much, but yeah, it was really great to be part of those groups because I learned a lot about people in the space and what they were thinking about and what they were looking for. So I really enjoyed that participation.
What kinds of standards are you talking about? So is it like safety, durability, like temperature resistance?
Yeah, I mean, even it depends on what it's for. But for example, like I think there was a standard they were working on around conductive threads, and it's kind of like,
Ah.
how do you categorize these? What are the important properties? How do we evaluate this from an electronic standpoint? So that when somebody wants to buy conductive thread for a professional purpose, they can look at the standard and kind of like know what they're buying and what it can mean. I worked on a standard about the 7 layers of building an electronic textile, which is like insulation, conductor, integration, patterning, components, like patterned in components, added on components, and like connectorization, so something like that. So it's just like if you're building an e-textile, even though it sounds like one thing, you actually have these 7 factors to consider. And that sort of comes back to how we do our e-textile, right? We, for the conductor, use a mesh versus a printed ink. They're both viable options. For our
Mm.
insulation, we use TPU film, which most people use the TPU film. So it's a very standard option. And it's like you have to sort of build your stack in order to, like, you build your stack to perform the way that you think that it needs to perform for the industries that you want to serve. And I think that, you know, in e-textiles, it's really easy to think like, oh, wouldn't it be fun to knit a circuit? And like, yes, it would be fun. But are you going to like base all 7 layers of your stack on this like fun idea, or like what do the customers need to select each material?
Absolutely. Oh, I'd be really interested. You've got this blog on your website that has a ton of really interesting stuff on it, including there was one down here that optimizing athletic performance with e-textiles, which seems to overlap a little bit with what Maker Block was talking, or Maker Brains, my bad, was talking about a
Yeah.
second ago. and just like tons of other stuff. And I'd love to, maybe you've already covered this on there, but the 7 layers of your stack up for e-textiles, that sounds fascinating. And
Yeah,
I know that
they're probably like ages and ages back. It's so old, but yeah, I have to dig it out at one point.
Okay, here's a question. On your site, you call out AR and VR applications as one of the various places that people apply Lumia's technology. Is this mostly like wearable, like controller and sensor type things, or are we talking about like things that go into like headsets,
Mm.
or cabling? What kind of applications overlap there?
Yeah, more of cabling or sort of garment-based stuff. Like if you know of the Tesla suit, like an interactive AR VR suit kind of thing, or like gloves. We don't really do anything with headsets. Like I think that also feels intuitive, but we just never gotten a customer for like an AR VR band or something like that. Um,
Mm.
yeah, we did work on an EMG headband, which is kind of interesting. It's like
Cool.
electrodes for like brain monitoring and stimulation. Or I guess EEG, sorry, EMG is
Mm.
muscular, but yeah, no headsets yet. Yeah, no Oculus kind of things, but maybe one day.
Oh, I'm hugely into EEG stuff, so that sounds fascinating. Is there an industry that you'd like to work with that you haven't had a chance to yet?
Um, let's think. I would really love to work on an MRI antenna because I
Oh,
think the use case is super interesting. And like I know there's another company that does print electronics who has made like more conformable MRI antennas, but for children. And I would love to
wow.
make a conformable MRI antenna for adults, or I guess also for children, for whoever needs one, whoever's going in. But yeah, that would be a really fun application. We just don't have a customer there yet.
And you've already done some antenna stuff that people can look up on your website, customization and all that good stuff. And there's a bunch of developer materials as well that people can get hold of if they get in contact, which I have lost the page for that. Here we go. Resources page. If you just click on resources in the top header bar there, then you can sign up to get access to all these different types of resources. You've got data sheets, code snippets, integration videos, etc. And I know I'm very excited about the stuff you've published on Hackster. Would love to see more of that. And obviously, I'm gonna dig out. I think I'm gonna end up cannibalizing some of the stuff that's already on Roku V1 and see if I can like reapply it to the new version. I've got this like headphones case that's super cute, and I think this would be like a great way to integrate. We've got a little servo connector in there already, but like this, I feel like
Super cute.
they look so good together. Okay, sorry. Enough about that.
If you need any components, just tell me and we'll send them to you.
Oh my goodness! And oh man, I'm sure that you're already doing a bunch of really cool stuff with developers. So folks, absolutely get in touch. If people want to, I mean, obviously we go to Lumia.com to learn more. We're coming to the end of our spot here, so I want to make sure that people know where they can go for information. So we've got Lumia.com. You do have an Instagram where you're posting lots of cool stuff, and I don't know why these notifications are popping up here now, but anyway, good place to follow everything that Lumia is posting. Also, you folks are on LinkedIn. Folks can follow Maddy, Maxey on LinkedIn to find more cool stuff that Lumia is getting up to. Go click through the website and see all the different interesting applications. Of course, check out the Smart Skin Tactile Sensor Developer Kit. And there's a really cool user guide actually as well. And all these different applications. Go check out Matrix Makers if you want. And of course, follow Lumia on Hackster. They have both a user who's publishing these tutorials that you can follow as another user. In fact, I'm going to go do that right now. Oh, I already am. Okay. And there's also the platform page, which is where you can become part of the community. You can see all projects that are going to be published both by product and by the platform as a whole. Just go to Hackster.io/Lumia and you'll be able to find all that good stuff, as well as this requesting a free sample. Wow.
That's exactly the reaction. Yes, correct.
Just like I get so excited looking at this stuff because to me, it's just this amazing. It does what it does so well, and this like it's almost like magical the way that it's so. This is deceptively not flexible because, in fact, since this is broken already, I'll just peel off the adhesive because this adhesive protective backing actually adds a lot of stiffness to the thing, and I just gotta express like how cool and magical these things are. I know that that's not necessarily, maybe magical isn't exactly the thing you're trying to like get your clients to think about, but it is. Like, look at this. Okay, I'm gonna stop freaking out, and but everyone, go check out the cool Lumia stuff. It's so drapable and neat, and you're just really doing inspiring stuff on the technology side as well. I think your approach is very interesting, and I'm monopolizing this, so I would love to hear if you have any few like comments that you'd like to throw in there, any thoughts that we didn't quite get to before we wrap up here.
Yeah, I think that's everything, and thank you for making our product look so good on camera. And hopefully this won't be our last Hackster Cafe. We really appreciate you having us on.
I'd love to have you on again anytime. And thanks again, Jennifer, for the awesome demo. It's so easy to make this stuff look good on camera because it's just gorgeous. It's designed for the inside of stuff, but it looks great on the outside too. Everyone check out the other demos with humanoid robotics. Tons of stuff on the blog. Go follow Lumia. They're awesome. All right. Thanks, everybody. So great having you on. Please do come back at some point. We'll make it happen. We've got some new comments that I missed. Aha! Indeed. Whoa! Lumia plus Edge Impulse. That'd be an interesting combo.
Edge Impulse?
So, yeah, Hackster is doing a bunch of stuff with Edge Impulse who allow you to run custom machine learning models on the edge, so on microcontrollers like Arduinos and stuff, like the one in the kit.
Familiar with them.
Oh, yeah, they do really cool stuff. Make it really easy to drop a bunch of your own custom samples of anything. Like it could be a microphone, it could be, light sensors, any kind of sensor that you can input, like so pressure stuff for maker brains. I'm guessing that well, actually, you already talked about the toes project. That would be an ideal use case where you're just inputting a bunch of samples and like tagging them with what they represent, and then in the future you can identify, for example, like excessive pressure in some particular area, or like a good or bad distribution of weight, or like whatever you want. Really cool, an interesting set of things to incorporate. Thanks again, folks. We could go on about this. I feel like there's so many rabbit holes I want to dig into, but we're out of time. So thanks again. Thank you everyone for joining, and hack on.
Well, thank you everyone.
Thank you.
Cheers.